Hi everyone, my name is Julia Lichbinska, and I welcome you to our new podcast series, Collect Yourself. Some people collect art and watches, and the outstanding personalities collect themselves. Stay tuned. Can you maybe tell us how your interest for astrology started?
Oh, that goes back. Astronomy.
Astronomy, sorry.
Yeah, I won't correct those mistakes. That goes way back to my father, who he was a forester, but he questioned everything around him in nature. He used to love trying to understand how things worked, from how a tree gets the liquid from the roots to the leaves up 100 meters. This was an unsolved problem. It's still not completely solved in science, actually. He was also interested in the universe, and he read books about quantum mechanics and black holes, but he never had the chance to go to university. And I used to go working in the woods with him in northern England, and the weather was horrible and it's hard work. And I didn't want to do the same hard work job. I wanted an easy life. And he said, look, go study, go to university and answer all these questions I have about the universe. So I did that. I studied hard and went to university to study theoretical physics and then astrophysics and then a PhD. I don't think I could answer many of his questions before he died, but some of them for sure, and he was quite proud. So that's a short summary of how I ended up being an astrophysicist. I didn't want to work hard.
Okay, see.
But it's also this, my father made me question everything, and that's what I do today. And it annoys some people because I don't ever believe what anyone tells me. I need to know how they discovered that, or the facts. So I question everything.
Ben is also author of many books. And in one of the books, which was also supported, I think the beginning introduction was made by your colleague, an astrophysicist from America, Mr. Cross, right, if I'm not mistaken. He's writing about certain romance in astronomics. Do you have also like some emotional aspect of studying and working in this field?
Yeah, I mean, who doesn't? When you go outside in a dark place, which unfortunately there's not many dark places, you have to get outside the city, and a lot of the world's population have never seen the Milky Way, which is sad. But if you go out into the mountains on a night and look up, I mean, it's inspirational to see the stars and the moon, just what you can see with your eye. And then I became interested as well with looking through telescopes, and I can show some pictures of what I've taken. And this is quite magical, being up all night in a quiet place. I have a little cabin in the mountains near Davos where I have my little observatory, and I'm quite happy alone there, just looking through the telescope all night, taking images of cool objects in the night sky, things you can't see with your eye, but with a telescope you can. And I have some pictures I've taken I can show you.
With pleasure. Also, taking pictures, is it a certain hobby? Because what you write in your book, that now astronomers, they're not having chance to get to the telescope, because you just give the coordinates and the machine calculates everything by itself and just makes the movies or photos what you need. Is the taking photos, I mean, we also have one example here in the back made by you. Is it a form of, retrograde hobby in astronomy?
It is very much.
Okay.
When I was a PhD student, I went observing with a colleague. I wasn't allowed to touch anything because I was just a student, but I was surprised because you don't get to look through the telescope. You sit in a room which is away from the big telescope. You never get to see it. All you see is a computer screen with the data coming in. And now when you use the space telescopes, it's even worse. You apply for time on a space telescope, and then 6 months later you get a directory and you download your data. So it's removed from looking through the telescope with your own eyes, which is quite a cool thing to do. Yeah.
So maybe we can have some photos.
I can show you some photos. I went to, with my colleagues, we took 3 telescopes to Namibia this summer. And so that's my colleagues setting up one of our telescopes in the middle of the desert in Namibia. And the advantage of going there is you see the southern sky, which is actually more beautiful than the northern sky, because you can see the center of our Milky Way. But also you're guaranteed good weather in the winter in Namibia. This was July. 99.99% chance of clear skies. So every night you have 12 hours of darkness, and we would set up the telescopes, and that's me and my colleague with 2 of the telescopes at night, getting everything working with red lights so we don't interfere with what we're taking images of.
Did you have some purpose of going there? Some specific task which you wanted to solve?
Sort of, yeah. We wanted to take images of galaxies in preparation for a space mission that I'm working on. So we have a space mission to be launched in 2030 to take real images, very deep images of nearby galaxies. So we had a plan to take images from the ground to see what the objects were we were looking at. So there was a plan. This is the telescope that one of the big telescopes we took. It's quite complicated because you have all these cables and power banks and laptops, and it's just getting it to Namibia was quite complicated. In addition to taking pictures of the galaxies, though, we couldn't resist taking some images of the night sky. And this is one picture I like. It's called the Fighting Dragons of Ara. It's a nebula in our Milky Way. Looks like 2 dragons fighting. It's a star-forming cloud of gas that's forming new stars today in the plane and the disk of our galaxy. That's one of the cool images we took. You can also have fun at night with lights, taking the Milky Way. That's me with the flashlight. The interesting thing, so this is the night sky. This is what you see in the northern hemisphere. If you just have a wide-angle camera and point it up and take an exposure, you see this part of the galaxy. That's all you see. But in the south, you get a different view of our Milky Way because you're looking down in a different direction across the galaxy. And there you see the middle of our galaxy from the southern hemisphere. So this is the view of the night sky we had in Namibia. At the center of the galaxy here, there's a big black hole. There's a lot of interesting objects to take pictures of. You can even see these 2 galaxies by eye. These are the Magellanic Clouds. And these are small galaxies that orbit our own galaxy. So what I did, I took this is a picture I took of the Milky Way from Namibia, and it's many pictures all stacked together of the whole night sky. So this is the view of the night sky, which you could see by eye, although now you see a lot more because each of these exposures was 10 minutes long. So there's a lot more photons coming in. And there you see the pink nebulas, which is why I actually wrote to Nikki in the first place, because I came across her artwork, pink stuff, and I wrote to her and said, do you know that a lot of things in the universe are pink? And then she got very excited. Is that true? And I said, yeah, there's also a pink planet. And she's like, whoa. And these clouds of gas, when they start forming new stars, the light radiates onto the gas and it glows in a magenta pink. And that's what these objects are that you see in the night sky. Then the next picture I have is a close-up of Antares, one of the brightest stars in the night sky. This is really cool, this region. It's so much going on here. Antares, there's also a big star cluster here. There's these big inky black clouds here, gas that's so thick that it blocks out the view of the stars behind. And all of these colors are real. All of these colors are what the eye would see if you were there up close. This is a wider angle shot of those Magellanic Clouds, the small and large Magellanic Clouds. These were quite special to me because the first project I did as a PhD student was to understand how this galaxy was moving around our own Milky Way. I was really happy to see that. So I took an even closer up picture. And it's a mess. So you might see galaxies like our own, and they all look nice and regular and beautiful. This one's just an ugly pile of stars. It's not nice at all, but it's amazing because you can see it with your eye from the southern hemisphere.
But then maybe we come a bit some years back and to the days when you just moved to Zurich and you took the position at University of Zurich, and maybe you can tell a couple words because you know more about the particular what is specific about this chair.
Oh, I got a phone call from the president of the university. It's quite unexpected. It was like, hey, hi, Professor. No, I wasn't even Professor. Ben, we have a job. We want to start cosmology again at the University of Zurich, at the Institute for Theoretical Physics, which was a very famous institute where Albert Einstein had his first job there, and he submitted his PhD, and he got his PhD from the institute, from the University of Zurich. But he left soon afterwards. But there were other famous people, Schrödinger, who developed the whole theory, formalism of quantum mechanics, spent over 10 years in the same institute. But once Einstein left, then nobody was doing cosmology anymore. So I got invited to start a new research group doing cosmology again at the university. So that was quite nice. Nobody can live up to Einstein's reputation, but I was happy to have his PhD thesis in my office. Which I had on my desk, actually, and I didn't realize how much it was worth, but I had it on my desk. It's only 25 pages thick. Like most students, when they write a PhD thesis, you get this big book of 200 pages. Einstein's was literally 25 pages. Super impressive. And it's a way of measuring the size of molecules in 25 pages of simple, beautiful mathematics. And of course, that alone deserved a Nobel Prize. And then, a few years ago, the president of the university said, hey, Ben, have you seen Einstein's PhD thesis? It's like, yes, so it's worth like $1 million. Okay, you can have it back now.
Speaking about Nobel Prizes, you've just written a book. You just released Sternenstaub, if I'm correct.
Sternenstaub.
Maybe you can present it shortly, because we have some exemplars here.
Oh, this is a nice book. I like this one. I think it's the best book I've written. And it's got a lovely cover. It's the story of the scientists who deserved recognition but didn't get it. Because most discoveries in science are actually awarded to the wrong person, or they're named after the wrong person. You might find that strange, but it's bizarrely true. Even the person who discovered the Big Bang, that the universe is expanding, had a beginning in time. Even on NASA's website, it says this was discovered by Edwin Hubble. And they named the Hubble Space Telescope after the person who discovered the Big Bang. But it wasn't Edward Hubble. It was actually a Belgian priest who didn't get the recognition for it. So this is the story of 42 scientists who deserved the recognition. There's a few in here. There's 10 before Mr. Nobel awarded the prize. People like Immanuel Kant, who you might think, whoa, he's a philosopher, not an astronomer. But he made the first predictions of what our universe should look like, the cosmology of our universe, which were correct. And then Georges Lemaitre was the Belgian priest who discovered the Big Bang. And then we have so many ladies in science who had such a hard time doing science because before the 1960s, science was a man's job. Women were not even allowed to use telescopes before 1960. And some women that made great discoveries, like Jocelyn Bell, who discovered pulsars, these incredible objects. Her PhD supervisor took the credit for it, and he got a Nobel Prize for the discovery of pulsars when it was actually this lady, Jocelyn Bell. And so this is the book about these stories of scientists.
So a bit of justice for our science.
A little bit.
What was the reaction in the book from the Nobel Committee?
Oh, I don't think they've seen it. It's only in German, so I don't think they read German. I'll probably publish the English one soon, so then they might find a copy on their desk.
Well,
I'm lucky. I get paid a salary to think about the universe, which is nice. I mean, it's hard because it's hard to conceptualize the whole thing that you have all this knowledge. You have to put together all these pieces of information to try and discover something new about our origins or our future or how stars work or so on. And the problem in science that is a bit frustrating is that it gets harder and harder to make discoveries. There's so much we don't understand, but the questions that are left to understand are so hard, I don't think we'll see any answers in my lifetime. And to me, that's frustrating. Like, why are we here? Why did the universe begin? What is time? What is space? Etc. These are all questions we have no answer to, and I don't think we will have an answer to for quite some time. But apart from that, it's really nice to be able to be investigating science for the sake of science. There's no value to what I do. Astronomers don't. It's a little bit like art. All we do is contribute facts and knowledge, which is useless, like art. Art is useless. Astronomy is useless. But people love it. People like art, people like astronomy, because they like to know about the universe and where they are. But it doesn't feed people, right? You see what I mean? It's useless. No, I think the students like me because I'm not strict. So I'm more from the British side of humour and culture rather than being strict. And you know, when I came to the University of Zurich, I was the youngest professor, and I went into the faculty meeting wearing my hiking clothes and a t-shirt, and there was literally like 200 old grey men in suits sitting there. And I was like, I'm in the wrong place, I should go now. And I think it was hard to fit into the system here initially because they weren't used to having this more laid-back British way of doing things. So I think I'm okay.
Another interesting project which I would love maybe to discuss is your residency at Reitberg Museum, when you were there as a scientist in museum.
Scientist in residence. In residence.
Yeah.
At the Reitberg Museum. The Reitberg Museum is a beautiful museum in Zurich by the lake there. Yeah. They have incredible exhibitions. And they were doing an exhibition on cosmologies from different cultures, how different cultures perceived our universe, the beginning, different creation myths about our universe from all over the world. And they had artifacts and books and ideas and paintings. It was an amazing display, and they asked me to be part of it, to help them with curating this. And they gave me an office, and in the Reitberg Museum, I spent 6 months there, and I did a lot of small events with people who could, just a coffee. I would be there for coffee in the morning once or twice a week when people could come and ask questions about the universe and cosmology. It was very interesting.
But I would love to speak about one particular result of this residency, and it's the movie, 24 Hours of Universe.
It is difficult to make sense of the development of our universe owing to the enormous range of timescales involved. To make this a bit more comprehensible, let me rescale the entire 13.8 billion year history of our universe into one solar day. That is, into a 24-hour timeline.
Like the question which you ask, like, will humanity exist 1 millisecond after the midnight? That was really a big question for me. Will we do that? I mean, do you have hope for our humanity?
You can always have hope. That's all I can say. Let's hope. It doesn't look good, does it? It doesn't look good for humanity, the way it's proceeding. But if you look, some scientists that look at the history of human war and everything say nothing is really changing. If anything, it's getting better. Conflicts are going down. It's just that we read about them more in the newspapers and on the internet. So it's more, information is more available. I'm not sure it's true, because when you look at the world, it looks really shitty. And what we're doing to the planet is extremely bad in terms of destroying habitat and changing the climate. And if you look at that, then yeah, a bit more pessimistic, actually. I think it's 50-50 if we'll be here in 1 second after midnight. I don't know. I don't have a crystal ball.
Okay.
Yeah. All we can do is try our best individually, and you try and do what you can to minimize your impact on this world in a way, which is hard, because every time you fly in an aeroplane, you're contributing to warming.
Speaking about flights, there was a very special project where you made a limited edition of the watches. Because we have a person from watch industry, I would love maybe to have just a bit of introduction on that.
Yeah, that's one thing you mentioned that you might ask me about. So I put a picture in about this there. I got a phone call from a watchmaker, and it was, "Hey Ben, we're making a watch. It's the most complicated watch we've ever made, but we need help with it." And so I got involved at the start of the project with EVC to do this watch. It took 5 years to develop. The front of the watch is a normal watch, boring, so it has hands on it. It has a nice tourbillon that spins around in 3 dimensions, which just looks nice, but it also makes the watch a bit more accurate. But the cool thing is this and the back of it, which I worked on here. So the watch not only measures 24-hour solar time, but it measures sidereal time, which is what astronomers care about. We care about this clock here, because this time is 4 minutes shorter than the 24-hour clock. So this time, sidereal time, star time, measures the time it takes for the Earth to spin around exactly once. And that's what astronomers care about, is when the stars come exactly back to the same position, because the Earth has spun around once. But our normal watches, they measure something different, because as the Earth moves around the sun, it takes a little bit longer for the sun to come into the same position. It's hard to visualize. It takes 4 minutes longer. The Earth has to go a little bit further. So the normal time, it's not useful for astronomy. So once you have a clock that can measure star time, then you can turn around the watch on the back of it, which the bit that I used to build was you had a star chart on the back, which was personalized. So whoever bought this watch could give me their coordinates, and I would build them a star chart which would show them the stars overhead from their location, accurate at any time at any time. So this was custom built for every client that bought this watch. It's about close to a million Swiss francs. I think 800,000 Swiss francs it cost. So I have the GPS coordinates of some very, very wealthy people. So I used to build that. I wrote the documentation for it and explained how it worked. And then that's the first time I went to the Southern Hemisphere, because I've not worked in this luxury world before. I'm a scientist. There's an observatory, which is the world's biggest observatory in the Atacama Desert, the Paranal Observatory. the watch company booked the whole observatory. So all the astronomers had to leave, and they flew in 50 of the most famous journalists from all over the world, which stayed in their little houses that the astronomers would normally stay in. And then we had the whole observatory to ourselves, and they flew me by a private jet there to talk to them. And this is it was all too much for me. So after that project, I stopped working in the private world of watches. But it was amazingly interesting to see how the luxury world works and what money can do. You can buy a whole observatory.
Cool. That's a cool story. I would love to ask you about art. You are a scientist with a particular view on this world. What is art for you?
You shouldn't ask me about art. I don't know anything about art.
Yes, but maybe I know that you compose music, right? The soundtrack that we heard, it's probably written by you, right?
That's music.
How different is that from the visuals?
I'm not an expert in art. I think art means something different for everybody. For me, I don't like most art. I don't find it as nice as what you see in nature. So for me, the beauty I like to look at is the beauty in space, the universe, or a view of a mountain, an expanse of nothingness. That, to me, is what I like to look at. So you will find on my walls at home pictures of mountains.
Made by you.
Pictures of space. You will not find any human-made art, because I don't think human-made art can match the beauty of what you see in nature. That's my opinion. So, sorry, artists. I do have a couple of pictures from Ansel Adams hanging in my home, which I like very much. His black and white images of rocks from California. These are really nice. I mean, is that art? I don't know. It's, to me, yeah, it's photography, which is art. So, but yeah, I told you not to ask me questions about art. Of course, I love human creativity, though. When I see humans doing really creative things, that is something different. So I like to see creativity, be it in music, in whatever form of art. It's interesting that I think we are the only species on Earth that creates art. I'm not aware of any other life form on our planet that creates art just for the sake of it. Maybe dolphins, they blow these bubbles in the water, which they just have fun with. But yeah, it's one way of defining intelligence, if you had to define it, perhaps. Yeah, mating rituals, they can be very colorful. And then you have these fish that make the patterns also for mating. I make my own music with guitar, and now I played in an electro rock band doing electronic music called Milk 67, and this was based. So I would record stuff on my guitar, and then we would build electronic sounds around it, synthesizers and so on. But that was too heavy. I do have one video with a song, maybe this one. Don't know if it's worked. Now I like this classical guitar, but slightly messed around with electronically, but mellow and chilled out. These are some computer simulations we did of galaxies colliding together, and this soundtrack is from my last album. Every sound you hear in this song is just guitar. There's no other instruments. So you take the chords, play them backwards, you stretch them, you put effects on them, but then you make a whole ambience around the guitar, which I kind of like. I think that's kind of interesting. But the guitar, I play the guitar every night for an hour or so. It's the most relaxing thing for me to take my mind off other stuff, like the boringness of bureaucracy and administration at the university, things like that. It's a way of switching off, just to focus on something completely different.
Okay, brilliant. Thank you, Ben.